Okay. So welcome to the presentation of the master's degree in control system engineering. We have also some students here in presence, so welcome to all of you. I'm Angelo Cenedese. I'm the coordinator of the master's degree. I hope you can hear well and see the screen, the slides. In case, just let me know. We will also record this presentation and share it with you on our web pages. Okay, so let's start. The control system engineering has a long tradition in our university and in our department. This is, in a nutshell, what our master's is. So we have total credit units of 120. We agree that we can reach 126 formative units. We have a set of foundational courses, 24 CFUs, and we are offering 5 curricula that are related to the most active areas of control engineering. But it is also highly customizable in the sense that we have these 5 curricula that are with automatic approval. But in the case that you want to choose your own courses, you can do that. You have the foundational courses that are mandatory for you, but then you can customize your path as you wish. And in this sense, we are also offering a rich spectrum of courses from all the areas of engineering. We have a final project composed of an internship or research training plus thesis that can be composed together up to 30 CFUs. In particular, we have 21 CFUs for thesis and 9 CFUs for internship or research training. We will go back to this in a while. And clearly the course is in English, so it is entirely taught in English. The requirements that we have are quite simple in the sense that we ask you either a degree in information engineering, a bachelor degree in information engineering, or any other bachelor degree with enough credits in mathematics and physics, control engineering, or other ICT topics, plus certified B level. More specifically, this is the, let's say, formal enrollment requirements. So we ask for the bachelor degree in information engineering with no other requirements, or any other with 9 CFUs in control, so basic any control courses in our degrees, at least 12 CFUs in information-related subjects, from electronics to telecommunications to bioengineering, and so on, and 20 CFUs in physics and maths. Also, we have a requirement on the English language and a minimum graduation grade of 84. Okay, this is the program structure. So, in case there is anything you want to ask, just stop me and we can answer straight away. Otherwise, let's wait to the end and we can have a question and answer section. So this is the structure of our program. So we have the basis of these foundational courses that are 3 courses: system theory, control laboratory, and estimation and filtering. Then we have the 5 vertical paths: artificial intelligence, robotic systems, industrial automation, systems and control, and complex systems. And then we have thesis and research training or internship, other mandatory activity. The difference between the research training and the internship is that the internship is carried out inside the company, and it is managed by the central offices of our university, while the research training is done usually in our laboratories, and it has a simpler procedure with just the student's office and a mail exchange. But they're both valuing 9 CFUs. And they both required a tutor supervisor from the university. Oh, yeah.
Ask how many hours are required for the internship or research training?
Internship, it is 225 hours.
Year scores.
Sorry?
So it's the same as 3 year scores, but the research training will be the same amount of hours?
More or less. Let's say that the research training is not counting hours because it has not a formal agreement like the internship. But let's say that in terms of months, you have 1.5 months for the research training or internship and 4.5 months for the thesis. This is let's say how we split the 30 credits in 9 plus 21. And in general, the activities can be unrelated. So you can do your research training on one activity and the thesis on another activity. More often, you combine these in a project that is a bit more complex. So you start with research training or internship that is a sort of learning a procedure, learning machinery, study a new topic. Let's say nothing new from your side, then the thesis is requiring something new from your side. So this is basically the difference between research training, more, let's say, passive, and thesis, more active. You are more actively involved. I don't know if Zoltan, well, we have also here one of the colleagues from the student's office that you will meet, I believe, in the following years. So in the case that there is something more, Zoltan, please stop me. Okay, so we can, yeah.
Thank you very much.
You're welcome. So let's proceed with the description of the different curricula. Well, no, let's start with the foundational courses and mandatory activities. So I told you that we have these 3 courses: system theory, estimation and filtering, and control engineering laboratory, that are all during the first year. First semester, you will have this course that is basically the foundational course for all our path. And then second semester, these other 2 courses. And as I just told you, final thesis and internship or research training. Okay, the first curriculum that we have is the curriculum in artificial intelligence. And the idea is that we just sketched out this tagline, control meet learnings, because we have seen that in the last few years, we are encountering a revolution in control system engineering, where we actually are experiencing a quantity and quality of data that is unprecedented. So in this sense, we want to exploit this amount of data in order to build more proper, more efficient, more, let's say, responsive control systems. And to do this, we exploit learning, data-driven technique in order to improve our control systems, to model our systems from they may be from a chemical plant to a spacecraft, from an automotive system to model of epidemics. So any of these systems is suitable for data-driven modeling. And then we exploit also data in order to design the controller. The artificial intelligence curriculum is part of a more complex strategy activity that we are doing in our department. That is the AI at day, so artificial intelligence at day, in the sense that at the day we have, I would say, a unique situation throughout Italy, in the sense that at day we have expertise in control systems, in bioengineering, in computer engineering, in telecommunication, in electronics. That is a unicum in Italy. And we want to exploit this multidisciplinarity in order to, let's say, and let's propose to our students artificial intelligence program that is present in all our master's degree, in the sense that you will find artificial intelligence curriculum in control systems, you will find that in bioengineering, you will find that in control engineering, in computer engineering, you will find that in telecommunication. All these curricula will share the same classes. And in practice, we have a set of courses with mixed students cohorts that are attending these common foundational courses. And these are common to all the masters that we are offering you. So in practice, if we look from the perspective of this AI at day course track, we have 30 CFU of AI-related common courses, plus we have the mandatory courses for each master's degree. In our case, we have the 3 courses that I've just mentioned, so system theory, estimation and filtering, and control laboratory. And then we have elective courses for each degree. So in a sense, the AI at day, the artificial intelligence curriculum, has 2 sets of mandatory courses. The mandatory courses for control, where you have, let's say, a specific class of automation engineers, and then a set of courses for the AI path where you have mixed course with all our colleagues from telecommunication, bioengineering, and computer engineering. The 4 courses that we are offering in common are these 4 courses, so Foundation of AI, Machine Learning, Deep Learning, and Reinforcement Learning. And they are basically all first year and then part of the second year, first semester. Going back to our curriculum, so the match of the AI at day and the control system masters is this one. So you have 7 mandatory courses, the 3 courses mandatory for control, and the 4 courses mandatory for AI. And then you have a set of elective courses, core courses from automation, 1 course to be chosen from the elective set, and then 3 courses. Just entering the details, so here the 3 courses that we are offering are system theory, that is a theoretical course of how to model and control dynamical systems. Estimation and filtering, so how to design estimation procedure and filtering procedure, and a laboratory course. Then foundation of AI, basics of artificial intelligence, machine learning techniques, and we are designing this course in the case that you have already followed courses in machine learning at the bachelor degree, or you have not attended any classes during your bachelor. Deep learning, so new frontiers from the learning theory, and then reinforcement learning. So this is a sort of incremental path that we are doing in learning. Among the core courses, so automation-related courses, we have a set of courses related to robotics, so robotics and control, that is mainly focused on the industrial robotic part, robotic arms, let's say manipulators. We have mobile and network robotics, that is related to let's say, either autonomous vehicles on ground and in the aerial robotics and space robotics. And we have also a part related to network robotics. So from the single agent to the multi-agent part. We have a set of courses related to, let's say, control techniques. So adaptive and model predictive control, for example, nonlinear system and control, network dynamical systems, learning dynamical systems related to identifications of model from data. We have a modern digital control. So this is a control that will be reshaped starting from next year, and will introduce modern elements related to how to design a controller with digital and computer-based system, how to deal with actual problem that you encounter in designing automation for real-world scenarios. And we have also some very, let's say, modern course like industrial and edge machine learning and visual language action model for robotics. Set of courses from the, let's say, elective affine part. They are taken from other disciplines for computer science, for telecommunication, and among these, I highlight the computer vision that we have in two versions, one version of 6 CFUs and one version of 9 CFUs. Big data computer, game theory, natural language processing from the computer science group, learning from networks from the telecommunication group, convex optimization and advanced topic in optimization from our colleague in optimization theory. This is the distribution of courses, mandatory courses along the 2 years path. So during the first year, you have first semester with 27 mandatory CFUs in the first semester and 21 in the second semester. Second semester, just 6 CFUs, and second year, just 6 CFUs during first semester, and the second semester is completely free from mandatory courses. And this is the how we split between core courses and affine courses. So core courses, automation related, 54 CFU, that is the minimum for our degree. And we have a lot of affine courses. And this is a sort of, witnessing the interdisciplinary nature of this curriculum. And then completely free, you have 15 CFUs. Okay, there is also another thing that is meaningful to say with this curriculum, that is the possibility of earn some micro-credentials. So micro-credentials are courses that you take beyond the 120 CFUs and that are related to other master's program. In practice, you are doing the master program in control systems. You are taking the curriculum in AI in control systems. You add basically one course in telecommunication, and you earn a micro-credential in telecommunication. It is a sort of add-on to your path. And these are the courses that we have chosen for the micro-credentials. There are 2 courses from the bioengineering group, 2 courses from the computer science engineering degree, 2 courses from the ICT, so telecommunication degrees. Clearly, they are all related to artificial intelligence topic. Okay, let's come to the second curriculum. It is related to robotic systems, but it is it is easy to realize how robots are impacting our daily life now and how will impact our tomorrow life. They will be really pervasive. And by robots, we mean any automatic system that has perception, that has actuation, and that has some intelligence on board. So for example, a self-driving car or an automatic aided car is a robot in our perspective. And then we know industrial robots, mobile robots, robots for deep exploration in space and everything. So the idea of this path is to provide you concepts of robotics from the theoretical and foundational to the most application-oriented ones. And this is how the program is structured. So the three already mentioned courses, then our modern digital control, and then the two courses that I mentioned before, robotics and control, so manipulators, and mobile and network robotics, so autonomous vehicles, terrestrial, aerial, space vehicles, and network robotics. This is the core of our mandatory, curriculum, so our 6 mandatory courses. Then we complement this part with the elective courses. These are all the courses from the automation group, and here you can find many courses from the artificial intelligence path, so machine learning, reinforcement learning, there is deep learning here, and foundation of AI. Plus, we have the courses characteristic of control, so adaptive and model predictive control, modern techniques of control. We have, nonlinear systems and control. For example, we have some courses specific for the industrial path, so industrial robotics. We have a robotics laboratory here. We have the visual language action model for robotics. We have autonomous robotics. We recommend that you take one course in computer vision. Visual sensors are the most powerful sensor that we have in robotics. And here, since we are composing this pack with 15 CFUs, we have both the computer vision courses that can be taken within the affine group. So the courses that are not related to automation, but they are related to telecommunication and computer science, so on. We have a methodological course of dynamical system and Lagrangian mechanics that is very useful for robotics. And here you can choose two of these in order to complement our 6 courses here. And then you have other 2 courses completely free for you to choose. Distribution of courses along the 2 years, we have 15 mandatory courses, 15 mandatory credits during the first semester, first year, 24 second semester, first year, 9 second year, first semester. Second semester is free of mandatory courses. We have less requisitions in terms of mandatory courses with respect to the AI a day. And here you can see that the amount of credits that you are earning in control are much more than the AI at day curriculum. We are lowering the set of free credits. You will see that this table here is the same for all our 4 native curricula, meaning that we have the division 63, 15, 12 for robotics, for industrial, for complex systems, and for systems and control. Okay, industrial automation. So we are talking about modern industrial automation, and modern industrial automation is a powerful blend of automation as it is properly said, computer science and telecommunication. Often we are talking about hyperautomation in the sense that it is no longer the simple automatization of a mechanism, but we are dealing of sensors, we are dealing with industrial Internet of Things, we are dealing with communication protocols. So basically, cyber physical systems are within the industrial automation system that we are composing. In addition, we have humans. Modern control systems see that humans are collaborating side by side with robots. We are talking about cobots, collaborative robots. So in this course, we learn how to design this collaboration between humans and all the automation systems that we can see in our modern factories. We have to guarantee no stop in the production, high efficiency and quality of products. So resilience and atomicity. The path is designed in this way. So the three already mentioned courses, plus digital control, industrial automation, embedded real-time control, and modeling and control of electric drives. With these three courses, we believe that we'll have a complete overview of modern industrial control system. In particular, embedded real-time control is a laboratory-based course where you design controllers directly on the embedded hardware. Industrial automation is dealing with industrial networks, so it is, let's say, midway between telecommunication, computer science, and control. And modeling and control of the electric drives, it is dealing with one of the basic components of our industrial system, that is the drive, the electric drive, the motor. Plus, we have one course from our core courses, and we have to choose between 9 credit courses. So here we have machine learning, robotics and control, mobile and network robotics, industrial robotics, and learning dynamical systems, so identification of models. We have 2 courses from the elective set, and again, I recommend you take something from the vision area, because also in the industry, the cameras are the most used sensors for monitoring and for controlling the production. Yes, sure. In what sense? So these are exclusive. Either you take this course or you take this other course. You, let's say, cannot take both courses. We are offering these 2 courses in order to offer you a wide choice, 6 or 9 credit, first semester or second semester. And there is also one additional difference, that is this course, 6 credits, is taught by a colleague from the ICT telecommunication group, while this course, 9 credits, is taught by a colleague from the computer science group. So the flavor that is given to computer vision is slightly different. It's more, let's say, algorithmic and, say, based on procedures in the course taught by the colleague from computer science. And it is more related to aspects related to the coding of the image information in the course taught by the colleague from telecommunication. It is a slight difference, but it may be of interest to you to choose one or the other. Any other question? Okay. You can also see that also in this path, in this curriculum, we are offering many courses from the AI field, deep learning, machine learning, reinforcement learning. So these basic courses are quite important for us to be offered to you. And here I also stress the fact that we have this industrial and edge machine learning, that is a new course that is the adaptation of machine learning techniques to the specific, let's say, nature of industrial processes.
Okay, so it makes sense to take both courses?
Yeah. I recommend to take machine learning and then industrial and edge machine learning, or in the case that you have already taken a machine learning course during your bachelor degree, you can probably jump to this course without, because you have already a background in machine learning. This is what I mean. Okay. Distribution of mandatory courses is this one. So 15, 24 during the first year, 15 second year, 0. You have almost always the second year that is, the second semester, second year that is free. And this is the distribution that, as I said before, it is equal for all the 4 native control system curricula. Now we will come to the, let's say, most methodological curricula that are systems and control and complex systems. The difference between the two is that, let's say, systems and control is more control-oriented, engineering-oriented, while complex systems is more mathematical-oriented. There is a slight difference, and we will see that in the description of the classes. But here we want to let's say, to produce, let's say, an engineer to teach you all the methods and techniques from the most classical to the most advanced that allows you to master any problem, any challenge, both in the industry and in research. So we have cutting edge topics to prepare for innovation by developing both the analytical, computation, and methodological skills. And here you can see some examples, self-driving cars or automation processes. But here let's say the flavor is more pushed towards methodological aspects with respect to, for example, robotics, AI, or industrial automation, where the stress is on the system. That in that case is the robotic system, the automation system, and the AI system. Mandatory courses, here we have 45 CFUs, the 3 mentioned courses, plus convex optimization, learning dynamical systems, so identification and optimization procedures, plus it is mandatory to take 1 control course among digital control, adaptive and model predictive control, nonlinear systems and control, network dynamical systems. All 6 credits courses. Then you have 24, you see a very high amount of courses here from the control core courses, and clearly you can take any non-chosen courses from this pack here, so any from the control pack that you have not placed in the mandatory pack, plus any of these one. Machine learning, reinforcement learning, robotics and control, mobile and network robotics, biomolecular feedback systems. That is the new name of systems biology. Affine courses, just 1 among these 3. Foundation of AI, if you are keen of artificial intelligence, computer vision, if you are passionate of vision and camera systems, or dynamical system and Lagrangian mechanics, if you are more keen on just, let's say, formal mathematical aspects. And then 2 courses from the free pack. And here, again, you can see that we have the computer vision 9 credits in the affine set and the computer vision 6 credits, because we have to compone 12 here, in the free pack. Distribution, according to the course that you choose here, since some of first year, first semester, second year, first semester, second year, second semester, you have a slight different distribution of mandatory credits. So it is up to you to design your path over here. And again, usual distribution for core, affine, and free. Often to have the second year, second semester free is useful if you are taking, for example, Erasmus programs abroad, or if you want to dedicate the full semester for thesis in a company or these sort of things. Otherwise, you can easily take one course during the second semester of the second year. There is no great deal, big issue in doing this. Okay, complex systems. So again, methodological curriculum focusing on nonlinear network biological quantum system. And here we learn how to build models and controller from data and first principle using the mathematical tools. So you can see here that we are pushing towards more formal disciplines. So we have learning dynamical systems as we had before. We do not have here digital control, but we have, for example, machine learning and dynamical system and Lagrangian mechanics. And then one of these two, nonlinear system and control or network dynamical systems. So here we have 7 mandatory courses, then 1 from the affine pack and 2 from the core control pack. Again, you can choose any unchosen control course from here. You can choose as your elective course. Distribution along the 2 years. Here, in this case, since both courses suggested for the control pack are second year, second semester, you will have a mandatory activity during the second year, second semester. The distribution of core and affine is exactly the same. Finally, if you do not want to follow our, let's say, automatic plans, you can also build your own plans. It has to be approved by the teaching committee that is approving the proposed plans. And here, the only mandatory activities that you have are the 3 courses that you have seen in all our courses. Then it is up to you to choose elective courses in the core set, elective courses in the affine set, in order to build this number of credits. My suggestion is that you start with any automatic curriculum, and then in case you switch to a proposed plan. We believe, and according to our simulation, the 5 curricula that we are offering are provide enough flexibility to accommodate all your needs and desiderata. But in the case, you know that you have also this solution here. Okay, so I have completed the description of the curricula. If you have any questions about these you can ask now, or I can proceed with some other aspect of our master program. Okay, so we have many students that are enrolling different initiatives, students' projects. Here I just mentioned some. And you can see here that are extremely multidisciplinary very transversal among all our disciplines, and they are in collaboration with other departments. We are students working with the CubeSat project, so satellites projects, Race Up Formula Student team with our colleagues from the industrial department. This is our own project in the sense that since 5 years ago we started to attend this challenge, and we are doing pretty well. It is an autonomous driving challenge starting in November, ending in May. It is an international challenge, and students are designing algorithm for autonomous vehicle. And if they are admitted to the final stage, they are going in Romania, in Cluj, for a week of challenge and finals against all our international teams. And here we earn first place, 2 second place, and 1 third place in the last 5 years. Finally, we have this project, the UNIZEB projects, again in collaboration with our colleagues from the industrial department. It is a permanent living lab on zero energy buildings. So here we are doing with all the appliances for thermal energy, for managing controlling the temperature in the rooms and the HVAC systems and whatever. All these are just examples of the projects that you can enroll. And all these projects can be sold, let me use this term, as your research activity. So in the case that you want to take one of these activities, you can do your research internship within these groups. Okay, so something more. Now I will show you some slides about current research topics that may be interesting for you for thesis, for work opportunities, for PhDs. And I mentioned the PhD right now because any curriculum that you are taking can lead to a PhD solution. So it is not just the more theoretical curricula will lead to the possibility to enroll in the PhD program, but all, from the industrial to the AI to the robotics, and we have example for this. So let's start with our research laboratories. We have 2 research laboratories, the NavLab, that is the Industrial Application Laboratory, and now we have inside the NavLab robotic arm for industrial cooperative manipulation. We have the Ducky Town, that is this system here, cooperative mobility in a miniature smart city. We have a driver simulator for motion cueing and control. In a while, you will see that our colleagues is just leaving the control of the car to the automatic system. Here, the system is controlling automatically, following the path. And then we have a mobile vehicle communication system in collaboration with our colleagues from the telecommunication group. Then we have the Sparks laboratory, space, aerial, and ground control systems, where we are dealing with all the things that are related to mobile and network robotics. So we have multi-rotor platform, quadrotor, hexarotors, and we are going from the design to the experiments. We are dealing with ground vehicles. This is a video from the Bosch challenge that I have mentioned before. And this is a proper research laboratory in the mobile robotics field. These are just a set of our collaboration. The 3 ovals are related to universities, just a sample of the university we are working with. Research groups, research centers from CNR, the Italian CNR, from the France CNR, from UK, research centers, and so on. And here, just a subset of the companies where our students can find jobs and where companies with which we hold active collaboration. So, career opportunities. As you may see, the control and the automation field is extremely transversal, and you can find your career, your jobs in the automotive fields, automation and robotics, home appliances, power and energy, and it is also very easy for you to swap from one to the other. And also, several of our fellow students are faculties or hold positions in universities around the world. Here are some samples. Beniamino is working in the UK in the aerial robotics field. Elisa is working in a company, robotics company in close to Vicenza. Gianluca, assistant professor in Louvain. Diego, formerly in Mitsubishi in the US, now it is in Amazon. Laura Dalcol was in Scania Group Automotive, now she is doing AI. Michele, previously in ABB, now in Hitachi Energy. Sofia, robotics in BMW. Alberto, assistant professor. Giuseppe, assistant professor, KTH. Enrico, KTM, so automotive. Chiara, data scientist. Gianluca is with Aprilia Racing Team. Giuliano with Electrolux. Just a very short sample where you can see very diverse careers here. Taken from Alma Laurea, I'm not commenting on this, just I'm saying that you will find job even before you are getting the degree. You will be contacted even before of that. Some graduates like to continue with the PhD, and the PhD may lead to academic or industry careers, not only the academic career. Many of the people that I shown here took a PhD. Beniamino was one of my PhD students, and he's now in the company. Chiara, the same. Enrico, also. So PhD, and Diego as well. So PhD is useful both for a career in the industry and for an academic career. This is our group. I believe that you have already met some of my colleagues during your undergraduate courses. These are some of the research areas that we work on. So AI, guide driving simulators, network applications, robotics, quantum technology, neuroscience, system biology, automotive, industrial automation. And just to place some names aside to all these let's say areas, I have prepared this slide for you to in case you are interested to contact myself or my colleagues. Last slide with some contacts, and with this I thank you for your attention, and I will take questions if any, also from home. Okay. Yes, this presentation will be loaded on the Control System Engineering website. So in the case that you have any question, feel free to ask. Please. Oh. Yeah, you first.
What the future mobility project was.
Okay.
So, will be supported from the university or from any institute if we want to work on it?
So your colleague is asking about mobility opportunities. So we have a set
model and project. Yeah, it was more.
Sorry?
The future model networking project was.
Bosch. Okay. So yes, the Bosch challenge is supported by our own funds. So in the case that you enroll in the group that is taking the Bosch Future Mobility Challenge, everything will be, let's say, paid, both as for the components, for whatever you want to develop, and for the mobility to go to Cluj for the finals. Everything will be supported by us.
It be theory-based to show how things can work, or we'll have to practically implement in more sense?
Well, you have to do both in the sense that the challenge is a practical challenge. So then there you will find your miniature smart city, and they will ask you to move in the smart city with your car. The car is given by Bosch, and you can add some components on that car. You will develop your own algorithms. So there is a part that is basically methodological, but at the end you have to implement everything on the car, and you will have to move in the miniature smart city.
My internship, my thesis.
You can do your final thesis on that.
My second question is based on the internship and thesis.
Yeah.
So the internship is for 9 credits and thesis for
21.
Can we include the two, or how it is in general?
So as I told you before, these are two different activities. So let's say that I like to have one deliverable from you for the research training or internship, and one deliverable for the thesis project. For example, for the internship, you have one deliverable that is mandatory because it is all managed from the university offices. For the research training procedure, we do not ask for a report or whatever, but I like you to produce this report, this presentation, whatever your tutor is asking you, because practically we give you 9 credits, you show that you have done something. This is the, let's say, the deal. And it is true that you can combine this activity with your thesis, but the nature is slightly different. During the research training, that is, I would say, it is a activity that you are doing to learn something. But for example, it is impossible that from that month something that can be patented, that can be published, is coming out. Okay. While from your thesis, the thesis project is longer, it requires your own ability, so something new from you is expected to come out. So this is the difference. I hope it is clear. Okay. Yep.
Slides will be uploaded.
Yeah. We will upload both slide and the presentation. Control System Engineering website.
Just like you received the same message. Yes. We'll show the info.
Okay, for those of you who are at home, we will send an email with all the details for the presentation and so both the slides and the recording of the presentation. We'll send an email. Sure. Sorry?
May I ask a question about the courses?
Yeah, sure.
Yeah, I was wondering whether the pack of control courses, automation system,
Yeah.
Were more or less interchangeable. Maybe I could attend a part of one and a part of another. Maybe they could be somehow connected. May I maybe attend multiple at the beginning and then decide one of them?
So you are asking if you can mix these courses with.
May I attend a part of one course, and would it be used in the other course as well?
Okay, so let's say that all our courses are self-contained. Okay, so we are not requiring prerequisites in the courses apart from these courses here. These are mandatory, and we require all the content of these courses to be known by you for all the others. Okay. But for example, in mobile and network robotics, there is some aspect that are related to nonlinear systems and control. Okay, but this is the course that I'm teaching. I will repeat and I will provide all the information about nonlinear theory that you need for this course. So there is no interdependency among the courses.
But I would ask exactly about the control part. For example, could I attend and see at the beginning which courses are more interesting to me?
Yes.
And then, for example, having a week in one course, would it be used in another? So would the information be similar to these courses at some point?
Well, the topics are different from the different courses. So usually the first lecture is used to provide you an overview of the course that is useful for you to decide if you want to attend one course or another. But if I understand correctly, in my opinion, it is not useful that you take, let's say, half on nonlinear, then you jump to mobile and network robotics, because you lose all the first part of this course that is useful for the second part of that course. If you haven't decided yet, you just take, I would say, the first week in order to decide. And you attend all the courses that you want. You will jump from one class to another. But I suggest that you decide during the first week. I hope this is
This question regarding the collaboration there on the slide for university collaboration and industry collaboration.
Yep.
So when we say university collaboration, so what we expect from this, like if we are working on project or some courses, so we can do with the student from another university. How is it like?
So when I talk about collaboration, I mean that these are companies with which we hold a collaboration agreement related to research and related, for example, to internship and opportunities for you.
Collaboration with other universities.
There may be also some other university involved. The important part is that you are a student, so your main objective is to get the degree. We will never send you in a company just to provide, let's say, free support to the company. Let's bear with me with this term. Your objective is to get your degree. So all your activities, if you are doing your internship, if you are involved in a research project, is that you can complete your thesis within 4 months and a half, within 6 months if we join also the research training or internship, and that at the end of this period, you have your thesis done. Okay. There may be involvement with technical offices of the companies. There may be involvement with our research laboratories, our colleagues from our other departments, other universities. Okay. Okay. Any question from home? Is everything clear for you? Okay. I don't know if Zoltan has something to add. Okay. Anything for you? Okay, so I believe that we can stop here. And thank you for being here, for joining our meeting, and I hope to see you in our courses. In the case of any questions or curiosity, just drop me a line by email or visit me in my office, and I go back to hear our contact details. And thank you again.